Welcome to EEMS 275. In this video, we will provide guidance on how to add a withdrawal return boundary to a water quality model. Let's get started. Open EE, then load the Lake T water quality model, which can be downloaded from the EEMS website. After loading the model, save it as a new model by going to the Model menu and selecting Save Model As. Enter a new name for the model run. For example, WR for Withdrawal Return. Then go to External Forcing Data in the Model Control, and right mouse click on the Withdrawal Return tab to display the options, and select Add New Data Series. The Boundary Series data form will then pop up. In the Boundary Series data form, click the Add New button. A default for the series will be created as Series 1. You can enter a new name in this field and press Enter to accept the new name. Clicking the Columns tab in the form, we can see that there are 26 columns including time, flow, salinity, temperature, and others. Select the Data Series tab to see them arranged in a horizontal grid. We will need to fill in these columns. A spreadsheet of time series for the withdrawal return condition needs to be prepared in advance. This will have the same number of columns as the boundary series data form. Time is in Julian days. Flow in meters cubed per second is the actual flow rate from withdrawal cell to the return cell. Other columns for salinity, temperature, dye, water quality, and chemical fate and transport provide the different values of concentrations of the withdrawal cell to the return cells. The positive delta values represent the higher concentrations in the return cells compared with the concentration in the withdrawal cells. Conversely, a negative delta value represents a drop in concentration in the return cell compared to the withdrawal cell. Copy the withdrawal return time series from the spreadsheet, then paste it into the grid in the Data Series tab of the Boundary Series data form, and click OK to close the form. In order to define which grid cells will be assigned as withdrawal or return, we need to see their location in the 2DH view. A withdrawal return location file should be prepared in advance. This file contains 3 columns: X and Y coordinates and a label. Click the new 2DH view button from the main toolbar in EE, and the 2DH view window will pop up. Click the Import External Layer button from the Layer Control. Browse to the withdrawal return location file and select Label Files from the drop-down list, and then click the Open button. We can turn off the bottom elevation layer in the Layer Control to see the label for withdrawal and return more clearly on the cells in the 2DH view. Select the Boundaries layer in Layer Control. Turn on the light bulb to show the layer. Activate the selection arrow and pin to show the boundaries in the 2DH view and make them editable. Left mouse click on a cell which has the R return label. A yellow box will show information about this cell. Take note of the L number for this cell. Left mouse click on the cell which has the W or withdrawal label, and then right mouse click to display options. Select Add New Boundary Group. The Add BC Group form will pop up, and then enter a name for the boundary group. For example, pump. Select the withdrawal return structure for boundary group type from the drop-down list. Then click the OK button, and the withdrawal return boundary condition form will pop up. In the current boundary group frame, select Controlled using time series for time control. In the return cell frame, fill the L value number which was previously determined. Then press Enter to update the information for the return cell. In the Withdrawal Return Flow and Concentration Rise-Fall Settings frame, select the WR time series, for example, WR from the drop-down list, for time variable series. Then click the OK button to close the form and return to the 2DH view. As a result, we will now see the withdrawal return boundaries are displayed in the assigned cells. After assigning the withdrawal return type to cells, we should save the model again by going to the Model menu and selecting Save Model or using Ctrl S. Now the model is ready to run. When we look at the model results, we can clearly see the impact of the withdrawal-return boundary in these cells. Thank you for watching. You can use the link below to view the next video in the series.